So now we need to make the graphs a little bit more involved, and it will take more than just one colored pencil for these. Again, when you did that Desmos activity, you saw that if there was a number out front, it sort of changed the slope of our graph a little bit. That might be how you referred to it. I actually want to use slightly different language here. I want to say if we're multiplying our function by a number, it's going to create a vertical stretch by a factor of a. For example, maybe y equals 2 times the absolute value of x. The reason I want to talk about this in terms of a vertical stretch rather than changing the slope is we're going to see as we move through this course, these rules will apply to any graph that we look at. It'll deal with parabolas and other things. When we deal with parabolas, we can't really talk about slope. We don't have straight lines on the two different sides. But we can still talk about a vertical stretch. What this is really going to mean is we're going to multiply our y values by whatever that a is, by whatever's out front before the absolute value bars. We're going to multiply our y values by a. I'll show you how to do this in a moment. The other thing that we saw, do you remember from the Desmos activity what happened when we stuck a negative number out front, like y equals negative the absolute value of x? A negative out front is going to flip our graph over the x-axis, or reflect it over the x-axis. This means flip over the x-axis. Take a moment, get that chart copied down, and then we're going to take a look at a bunch. We'll fill in stuff on the bottom in a little bit, but right now I'd like to move on to page 19. And before we do anything, I want to start this the exact same way we did in the last video. I want to graph y equals the absolute value of x on each of these 4 grids. So 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. Take a moment, get that graph on all 4 of these grids. Actually, you know what? Why don't we take care of all these problems on those 4 grids and the 4 problems on the next page? Let's get that function in there so we can save a little bit of time later. Again, when you're done, go on and do E, F, G, H as well. Just get that parent function on each of those grids. So the first one we're going to graph is y equals 2 times the absolute value of x. And I'm going to do that in a different color, and I'm going to color code my work. As we said on the previous page, this number up front is a vertical stretch. I need to multiply my y values by 2. Right over here, this point had a y value of 0. My new y value is 2 times 0, still 0. This point had a y value of 1. My new y value is 2 times 1, or 2. This point had a y value of 2. My new y value is 2 times 2, or 4. This point had a y value of 3. My new y value is 2 times 3, or 6. I'll do the same over here. Y value of 1, new y value is 2 times 1, or 2. Y value of 2, 2 times 2 is 4. Y value of 3, 2 times 3 is 6. I'm going to go connect the dots. And I'll get something like that. That pink graph is what y equals 2 times the absolute value of x is going to look like. Next, in letter B, that negative number up front. Well, we said a negative would flip it over the x-axis. This point is right at 0, 0. This point was 1 above the x-axis. If I flip it over the x-axis, it's now going to go 1 below the x-axis. This point was 2 above the x-axis. I'm going to flip it so it's 2 below the x-axis. This was 3 above. It's now 3 below. I'll do the same on the other side. 1 above, now it's 1 below. This was 2 above, now it's 2 below. 3 above, now it's 3 below. I'll go connect those dots. And I'm getting something like that. Another way you could think about this one is you could say it's like there's a negative 1 out front before your bars, and we could multiply all of our y values by negative 1. 1 times negative 1 is negative 1. 2 times negative 1 is negative 2. 3 times negative 1 is negative 3. It'll get you the same graph. I'll give you a moment to get caught up. Now, moving on to letter C, y equals negative 3 times the absolute value of x. Well, we're just going to go and multiply all those y values by negative 3. What do you think the 3 is going to do to our graph? Is it going to make it wider, or is it going to make it narrower? Well, that's a vertical stretch by 3, so I think if we multiply things by 3, it's going to kind of pull everything up. It's going to make it narrower. What's the negative going to do? That negative, that's going to flip it over the x-axis. So we're going to do two things at once. We're going to make it narrower, and we're going to flip it. And I can do all this work by just multiplying my y values by negative 3. 0 times negative 3 is negative 3. 1 times negative 3 is going to be negative 3. 2 times negative 3 is going to be negative 6. 3 times negative 3 will give us negative 9. I'll do the same on the other side. Negative 3, negative 6, negative 9. I'll go connect those dots. And we're going to get something like that. Take a moment, finish that one. Letter D. Y equals a half times the absolute value of x. Well, I'm going to multiply all my y values by a half. So, this point over here had a y value of 0. A half of 0, still 0. This point has a y value of 1. Half of 1 is a half, or 0.5. I'm going to put a point about halfway in between there, like that. This y value was 2. Half of 2 is 1. This y value is 3. Half of 3 is 1.5. Why don't I keep going? You know what? This y value would have been 4. Half of 4 is 2. I'm going to do the same on the other side. A half. 1. There. And connect the dots. So take a moment to get caught up on that one. What we now need to see is how to put all these transformations together. And there's a particular order we're going to need to do things in. This graph, there's a 2, there's a minus 3. It's actually going to make a difference if I multiply my y values by 2 and then subtract 3, or if I move everything down by 3 and then multiply the y values by 2. The way I figure out what to do first is I think about what would happen if I plugged a number in for x. If you were to plug a number in for x and take the absolute value of that number, what would you do next to that number? Would you multiply the number by 2, or would you subtract would you subtract 3 from that number? Well, I think if I was plugging in something here, I took the absolute value, I would next multiply it by 2. Because of that, that's the next transformation I need to do. I need to go do y equals 2 times the absolute value of x. Well, you know what that means. That means multiply your y values by 2. Take a moment and do that. So I'm getting something that looks like this. If you went to plug in a number here, you take the absolute value, then you'd multiply by 2. After doing that, you would subtract 3, which means now what I need to do is subtract 3 from this pink graph. Well, subtracting 3 outside our function moves it how? I think subtracting 3 outside our function should move it down 3 spaces. So I'm going to do that. I'm not going to move the green graph, though, down 3. I'm going to move that pink graph down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Over here, 1, 2, 3. 1, 2, 3. 1, 2, 3. I'm going to connect the dots. And my final graph for y equals 2 times the absolute value of x minus 3 is that light blue graph. Again, I need you to color code your work so I know what exactly I'm looking at when I go to grade these things here. Take a moment, finish that one up. In letter F, there are 3 things that we need to do. The negative, the minus 3, the plus 1. If you went to plug in a number for the x, what would you do first to it? Would you change its sign? Would you subtract 3 from the number? Or would you add 1 to the number? I think the first thing we would do is subtract 3 from our number, which means that's the first thing we need to graph. Y equals the absolute value of x minus 3. What does that mean? How will my parent function get transformed? I think that minus 3 means go right 3. Take a moment and go do that, please. And I moved my graph to the right 3. If you were plugging in a number, we'd subtract 3, take the absolute value. The absolute value just gives us our V shape. That's not a transformation. But the next thing we would do is we would change the sign. We would make the thing negative, which means that's our next transformation we need to do. That negative is going to flip your graph over the x-axis. So please go do that. Take the pink graph that I have and flip it over the x-axis. Finally, we have the plus 1 to deal with. What's this plus 1 going to do? That plus 1 should move it up 1 space. So, I'm going to take all the points on my blue graph, your colors might be different, that's fine, and I'm going to move everything up 1 space. Go do it. that orange graph is what our final graph should look like. Now, if you're not liking what I'm talking about when I say, like, if we were plugging in a number for the x, what would we do first, second, third? There's another way we can deal with this. Can you take a moment and go back to page 18? On the bottom, in general, our transformations are going to look like y equals a times f of x minus h plus k. Notice the minus h is inside the function, the plus k isn't. The a is multiplied by our function. In general, when we're graphing, the first thing we need to do is deal with any horizontal shifting. First, deal with any horizontal shift, the h value. The second thing we're always going to have to do is deal with that number up front. Deal with any vertical stretching or flipping. Vertical stretching or flipping. Deal with the a value. When we're done, we'll need to deal with that thing we're adding or subtracting at the end, any sort of vertical shift, which means deal with that k value. And this is the order we are always going to go in. Horizontal shift first, then vertical stretch or flip, then vertical shift. Get that copy down. And we're going to take a look at two more graphs. Letter G. According to our rules, what's the first thing we would need to do in letter G? I would need to do my horizontal shift first. So we're going to graph y equals absolute value of x plus 4, which means you're going to go left 4. After that, you need to deal with any vertical stretch or flip. That's that a value up front, which means your final step, your next step and final step, would be y equals negative 3 times the absolute value of x plus 4. You'd multiply your y's by negative 3. Go do letter G. I'm getting a graph like that after my first transformation. Now I'm going to multiply those y values by negative 3. 0 times negative 3 is 0. 1 times negative 3 is negative 3. 2 times negative 3 is negative 6. 3 times negative 3 is negative 9. 1 times negative 3, negative 3. 2 times negative 3, negative 6. 3 times negative 3, negative 9. Connect the dots. And I think it should look like that blue graph over there. That's it. Letter H is about as tough as they're going to get for right now. What's the first thing we'd have to do in letter H? I think our first step's going to be y equals absolute value of x minus 1. Deal with your horizontal transformation, which means we're going to go right one space. What's the next thing we're going to have to do? We'll have to deal with that 1/2 up front. We're going to need to multiply our y values by 1/2. So y equals 1/2 times the absolute value of x minus 1. Finally, what do we have to do? We'll deal with the minus 4, which means we're going to go down 4. I should have labeled this as multiply the y's by 1/2. See what you can do here. So this is what I'm getting after my first step. Now I'm going to multiply the y's by a half. And then I'm going to go and move all those points down 4. I realize it's a little tricky to move the half ones down 4. It's okay. 1/2. 1, 2, 3, 4. It's still halfway between two lines between -3 and -4. We'll go over there. That'll go there. That'll go there. Same idea on the other side. I'm going to connect the dots and get something like that. And again, this is about as tricky as they're going to get for right now. Final thing we need to take a look at. We have a transformation of f of x equals the absolute value of x. I want to write the formula for these graphs. Letter A. Y equals absolute value. Okay, let's see. This graph was shifted 4 to the right. So inside the bars, what am I going to have to say if I'm 4 to the right? I think we're going to need a plus 4. I didn't move it up or down at all, so nothing at the end. However, there is a vertical stretch here. I guess I can use some slope ideas to figure this out. Any thoughts of what number is going to end up out front? Normally I'd go like up 1 over 1, but here I'm going up 3 over 1. I'm going to stick a 3 out front. Y equals 3 times the absolute value of x plus 4. That's kind of how I'm going to piece these things together. Letter B. Y equals. What's going to go inside the absolute value bars? It was moved 3 to the right, so I'm going to say x minus 3. Have I moved it up or down at all? What am I going to stick outside the bars at the end? Looks like it was moved up 5, so I'm going to say plus 5. What about the vertical stretching? What are you going to stick out front? I don't think this one was stretched, but I do think it was flipped. Down 1, over 1, down 1. Yep. So I'm just going to stick a negative or a -1 out front. That's kind of how I'm going to piece these ideas together. I realize this might have seemed kind of slow and dragged out. This is a really important topic, though. Here we're graphing absolute value v's, but we're going to use these exact same graphing ideas of moving left, right, up, down, vertical stretch, vertical flip throughout the entire year, and these ideas are going to make some very complicated graphs very, very easy if we understand these ideas in this video.